because the whole theory of quantum gravity isn't actually whole? I mean, parts of a comprehensive theory of quantum gravity are missing, right?
Yeah, no, that's a vital point. Whenever we talk about Einstein's general relativity or even Newtonian ideas of physics, we're in the realm of so-called classical physics, which means we're not taking into account the insights of quantum physics, which is the physics of very small things. And many physicists believe that we would take the ideas of quantum physics and meld them with Einstein's ideas of gravity, general relativity, then some of these features that we're talking about might go away. So for instance, the thought is quantum mechanics might prevent the possibility of time travel to the past from being executed.
Is it possible, in light of the fact that there is such a thing as quantum physics, I mean, there's always been quantum physics,
yes,
but it wasn't named, right?
Right.
Can one be a classical physicist today?
Well, you can...
Can you say, oh, I prefer the classical stuff?
No. There are many interesting problems in physics where the quantum implications are so modest that you don't need to take them into account. So if you're looking at the orbit of the moon around the Earth or the Earth around the sun, quantum physics hardly makes any difference at all.
Okay.
So if you want to predict a solar eclipse, you can do it using classical ideas. But yes, you're right, quantum physics underlies everything and ultimately does need to be taken into account and sometimes makes a huge difference.
Is that the idea that out there somewhere is a theory of everything that combines them?
Well, theory of everything is a curious phrase that I try to stay away from because it seems to suggest I'd be able to predict what you had for breakfast, and I don't think we're going to have a theory that
chocolate,
there it is,
chocolate.
Right? So there's a prediction. But the notion of unifying all our understanding of physics, general relativity, and quantum mechanics into one whole, one seamless whole, that is a major goal of physics today, and that would be a unified theory of the fundamental forces.
And is that where folks like you who know about string theory come in?
Yes.
The idea of string theory is trying to make that unified theory?
That's exactly the point. Einstein was the first to really articulate this idea of a unified description of nature's forces. He worked for 30 years to find the unified theory, and on his deathbed was still scribbling away, but never found the theory. And we think, underscore think, we don't know for sure that string theory may be the theory that he was looking for but never found.
Will you be scribbling away on your deathbed?
I don't think it'll be equations.
What, love poems?
Well, there you go.
Okay.
Maybe.
You know, I once read that Stephen Hawking, he worked on an escape plan for characters like Merlin and Amy Adams who would be stuck in time travel loops. It was called the chronology protection conjecture. And I love that Professor Hawking is so dryly funny that in his 1992 paper presenting the conjecture, he wrote, "It seems that there is a chronology protection agency which prevents the appearance of closed time-like curves and so makes the universe safe for historians." So Hawking's paper sounds like a great opening to a movie. But is there really something that is the chronology protection conjecture?
It could be, right? I mean, if you can travel to the past and the future, there are all sorts of potential paradoxes that come up. You've seen them, right? In movies, right? That's what we're talking about here. In Back to the Future, right? Marty goes back. If his traveling to the past prevented his parents from ever meeting, then how would he ever be born to be there to prevent them from meeting? So there's a paradoxical situation there. So how do you resolve that? Well, there are many proposals. Hawking's is one. Hawking's proposal